Hello everyone, welcome to a brand new video on blood typing. So in this video what we're going to be discussing is looking at a basic review of blood types, looking at their antigens and the serum antibodies. We are also going to discuss the agglutination reaction that's necessary to understand it, talk a little bit about how we test it, and then give some examples of the test results we might see for things like A positive blood, B positive blood, AB positive, O positive, A negative, B negative, AB negative, and O negative blood types. And we want to see kind of what's going on. So as we understand that, let's begin with a discussion of the first important term is this term antigen. Now an antigen, all an antigen is anything that causes immune response. Now it is important to note that the immune responses only occur when there are the antibodies against them present. But there are really only four major antigens we're going to discuss. We're going to discuss A, B, and O, which is the heart of the ABO blood group. And then we're going to discuss the RH antigen, also referred to as the D antigen, because that's the most common version of that, and that is another antigen. Now, I do recommend that you watch my video on the genetics of blood type to better understand this video. So if you haven't watched it, I have a video on the genetics of the human ABO blood type system, because ABO, A and B are co-dominant, so that means they are equally dominant to each other, so that's how you get the AB blood type, and they are both dominant to O. But RH comes in two types, a positive who has it, or a negative who doesn't have it, and positive is dominant to negative. So they are different types of inheritance patterns. Now, the next thing we want to discuss are the antibodies. Now, antibodies, these antibodies are something that you may know if you studied any kind of immune system stuff. But antibodies, these are proteins, immunoglobulins. We call them IgGs, immunoglobulins. And the immunoglobulins that exist out there, there's actually two major types, IgM and the IgGs that we're concerned about here. But they're what we call the anti-A antibodies. And those will attack A. And then there are the anti-B antibodies, and there are anti-RH or D antibodies. And they are against the things they say. So an anti-A antibody attacks blood cells with type A antigen. Anti-B antibodies attacks blood cells that have B antigen, and anti-RH or D attack cells with RH or D antigen. Now these antigens, A, B, and O, you have them, you're born with them based on genetics. But the antibodies here that you get, you actually get them as you eat certain foods or from gut bacteria that have the same antigens on it that your blood cells have. And your body will make antibodies against the ones that you're missing, that you don't have on your blood cells or your other cells. Now, D, you must be exposed to have it. If you want to see more about that, watch my erythroblastosis fetalis video. Now, as we talk about it too, I want to talk about what happens when we give these two things together. And to do that, I'm going to discuss, so let's say here I have a red blood cell here, and these red blood cells, let's say this is a type A blood here, and the type A blood, remember, has the A antigens on it. So these are A antigens. These are the carbohydrates sticking out. And if I took this blood here, and let's say that I took this blood from my body, and I put it in somebody else's body. In their body, they will have antibodies that, so here we would have, let's say we have anti-A antibody here. If I ever take this and place it into a solution where these antibodies can attack, they will. They will bond and they will attack these cells. And what will happen is these blood cells, they will have many of these antigens on it. And these antibodies will begin to attach. And when they attach, they might attach another one together here. Another antigen here might bond to that one. And they might have some more here that bond. And what you'll get is this massive amount, this clumping, where these antigens and antibodies, they clump together in this massive way due to all the antibodies that might be stuck to them. And they will form a massive clump that macrophages are attracted to, called an agglutination. They will what we call agglutinate. And when they agglutinate, they are clumped, and what will happen is ultimately this will lead to hemolysis, blood cell splitting, and it will be destroyed. So if we have these surface carbohydrates and they end up in a medium that has antibodies against them, they will coat it, they will start to stick together, forming agglutination. Now we can actually test that by basically, if we took test tubes, let's say I've got 3 test tubes. We're going to draw these 3 test tubes quite a lot today, so you might as well just get used to it. And one has anti-A antibodies in it, one has anti-B antibodies, and one has anti-D antibodies, or to say RH, same thing, remember. And that we have that liquid in here, and it's got those antibodies present in this liquid. And I take a bit of your blood from your body, if we had some blood, and let's just use an example of this. Let's say this blood is type A blood, and this blood gets added to each test tube. Then what will happen is, if these are the antibodies here, if these are the antibodies, and this is the blood type, then we have our blood type here, type A, and you put A in a serum, a fluid that contains anti-A, then you will begin to see clumps visibly forming here. You will see it will visibly agglutinate. Okay? Now, here, anti-B, it will just dissolve in it. That's it. There's no problems. It mixes. I would mix it up. It's not going to clump. Now, if we said this was a positive blood, and I put it in anti-D, it would also agglutinate. Okay? So I'm going to try to visibly make this a little bit more obvious that the blood is mixing by drawing it more like this, and say this is when it mixes. Nice kind of crosshatch here that it's mixed in it. And I'll draw clumps that it agglutinates. Okay? So let's look at this. So if we understand that that right here is what's happening to cause these agglutinations, and this agglutination here will cause hemolysis and destruction, and can ultimately cause death in the patient. It could be, so if you give the wrong blood type to the wrong person, let's say through a mistake, we didn't properly identify the person's blood type, things like that, then we would have a problem. Now, this clumping happens only when the antibody comes in contact with the foreign antigen, the one that it's against. And this can kill you as it kills your blood cells. Now, one of the things I do want to mention is normally during a blood donation, the blood, if we take a pint of blood and we give it to you, that person's circulating plasma antibodies are so diluted that when we put them into the patient, they generally have no impact whatsoever. They might affect a handful of cells, but they're so diffuse and dilute, it's no issue, okay? So what we are going to focus on is in a test tube environment. Let's say I have a patient here. We've already done A positive. So when we did A positive, we talked about it. This person here was A positive. We put that into test tubes here that had antibodies, anti-A, anti-B, and anti-RH or D, that when that blood gets added to these tubes with those antibodies in them, we saw those results, okay? We saw visible clumping here because any of the antigens that was on that blood there would have been clumped together. It did nothing. It visibly just mixed together nicely here and clumped considerably here as well. Now, with that, we could identify this patient as type A. So if you were to put blood into tubes and we got this result, then we would say they are A positive blood based on the results here. So let's try one and show you what would happen if I had a blood. Now I'm going to start with blood. I'm not going to tell you what blood type it is. And we're going to go in here. I'm going to get my 3 tubes again. And we're going to test these. Again, anti-A, anti-B, anti-RH, which is also called D, and that liquid in these tubes has those antibodies in it. Now, if I took this blood here and I add it to all 3 test tubes, and I get these results. So I mix it here, no clumping, it mixes in nicely. Here, I get some pretty widespread clumps. I get some invisible agglutination here, and agglutination here. So we know that this blood here does not have A on it. So then it doesn't have A, but it does have B. So we know it's a B blood. And it agglutinated visibly within the anti-RH, which means it is positive for the RH. Remember, RH positive, we just write positive, okay? So this is B positive blood. So let's see the next one. Let's take another mystery blood. So I've got a mystery blood here, and I've got my 3 test tubes filled with my magical antibodies here. My anti-A, anti-B, and my anti-RH. Remember, we can call that D. And it's a liquid that has these antibodies in it. We put this blood into all test tubes. And on this one here, we get something very interesting. We get clumps in all of them. So that means they possess all antigens. So this is AB positive blood. Okay? So that's kind of interesting there to see that. Now, what we're also going to see, so if we did this one here, let's say I had another one. I've got a mystery blood here. I don't know what it is, but I've got my 3 vials of antibodies in a solution here. So again, I've got my anti-A, anti-B, and anti-RHD, sorry. And I put this blood in these solutions, and here's what happens. We get no reaction here. It mixes just fine on that one. We get no reactions here. It mixes just fine here. But we get agglutinations, clumping here. So the only one that clumped, we got no clumping in A, so we know it doesn't have A. We know we got no clumping in B, so we know it doesn't have B. So that makes it type O when it has neither one of those. But it got clumping in D, so we know it is O positive blood. Okay? So you might begin to see a pattern here in what I'm doing, and it may become too easy for you on the next ones. But, so again, let's say now I did some changes around. I've got my blood here again. I've got my 3 wonderful test tubes here full of antibodies. Again, anti-A, anti-B, and anti-RH or D antigen. And these vials have those in it. And then I take this unknown blood and I add it. And here I get agglutinations here in A, but when I put it in B, it mixes without clumping, no agglutination. And when I put it in anti-RH or anti-D, nothing as well. So we already know this is A, but it is A negative. It is negative for the RH antigen. Okay, cool beans. So now let's see another mystery blood here, a mystery drop of blood. We've got 1, 2, 3 vials again, our same 3 vials with anti-A, anti-B, and anti-RH. Now I know you're like, oh, I'm getting tired of them always doing that, but it's probably better to practice it as many times as we possibly can. Now what we're going to do is we're going to take this, again, we have these serums, these liquids that have these antibodies in it. So on this one, I put it in anti-A and it mixes fine, no agglutination. I put it in B, it's clumping. Okay, we get clumps in that. So already we know this is B blood, and then we put it in anti-RH, mixes just fine, so we know it's B negative. All right, so I bet you already know what the next one is, but we're going to do it anyway, even if you guys are smart, and you are. We're going to do it anyway because it's important to kind of do these thought processes. So now again, anti-A, anti-B, anti-RH or D, and I've got those test tubes containing those antibodies. We put the blood into each one of these, and now what we're going to get here is, so on this one here, we have B negative. Let's say I did this one and I got clumps. I got clumping here, but here I got nothing. Well, it has to have both A and B antigen, but no RH, because remember in RH, if you don't have it, you're RH negative. We just call it negative, okay? So again, we have our negative there. Now, what if I did the very last one, and if you've been following along, you should know what the last one is. And so let's get the 3 vials again. And remember, we have our anti-A, anti-B, and anti-RH or D. And these liquids here, these solutions that have that antibody in it, and we add it to each one of them, and all we get is a nice, they mix in them all. This is a cell that has, these are blood cells that have no antigens whatsoever, so it's O negative blood, universal donor. So anytime you mix blood for a patient, it's going to be this is what we call O negative blood, the universal donor. Though it has anti-A and anti-B antibodies in it, they're so dilute, or we can remove them, so it doesn't matter. And this is very important as you guys go through this, because as you go through things like USMLE exam or any other kind of exams, healthcare programs, you will be doing that and understanding that we have an agglutination reaction happens. Well, you can imagine what would be going on in the body if this happened, in hemolysis and death of blood cells. So this does conclude my video on blood typing, and I hope you found it helpful and useful. Please let me know what you'd like to see in future videos. Don't forget to comment, like, and subscribe. And as always, thank you so much for watching. Have a great day.